How are you guys doing today? Good. So you know your exam is day after tomorrow. You know that, right? Your EXam1. So I posted the review sheet on Brightspace and I showed you last time. I'm going to show you again. Whatever we covered so far, it will be the exam will be based on these materials. And whatever we did not cover, I'm going to omit those from the review sheet, so you don't have to study those. And I'm going to tell you which questions are those. Hmm? Greatest integer function? Uh, you don't like that function? No? Okay. I'm not gonna put that in the exam then. So I'm gonna give all those derivative rules, all those limits, many derivatives, many limits, and then horizontal asymptote, vertical asymptote, domain, removable discontinuity, those things. And from graph, you identify the left side limit, right side limit, and what's the exact limit, those things. Any question before I start? How your school is going? How was your school today? You went there after 1 week, right? Most of you. How was it? Good. After a break, when I go to school or when I come to school, the whole day I feel so tired, so sleepy and everything. So how about you guys? How are you feeling today? Do you have energy left for my class? Coffee? Okay, so I want to start by apologizing about something I did in last class. So before I make the lecture on last class, I actually didn't review my materials. So I'm thankful to Ellen. Ellen, thank you. Thank you so much for pointing that out. I actually didn't realize that I missed my minus a from the formula. Okay, so the formula for the tangent line is actually this. Y equals derivative with a times x minus a, and then plus the y value for the x value. Okay, so we can find the tangent line two ways. Either plug everything in this equation and simplify, or you can find b individually from y equals mx plus b. So b is y minus mx. Find that and then substitute. It's up to you. So I'm going to do this question again, and this time I'm going to do it correctly. So this equation is telling us find the derivative and substitute x with the number they give us. And then if they did not give you any y value, then first find the y value also. So they didn't give us any y value. They're just telling us to find the equation of the tangent line for this function when x is 0. What would be the equation of the tangent line? So in the exam, there will be one question about equation of the tangent line, at least one question about horizontal tangent line. So in this question, we have, they gave us only x value. They didn't give us the y value. So I'm going to first find the y value, f of 0. Here our a is 0. So f of a, it means find f of 0. So 5 times cosine of sine of 0 to the 4, which is same as 5 times cosine of sine 0. And what is sine 0? 1. So sine 0 is 0. So we have 5 cosine of 0. And then what is cosine 0? 1. So we have 5 times 1, which is 5. So we have 5 here, x minus 0. And now only thing we need to find is what is the derivative when a is 0. So we go find the derivative. F of x is 5 cosine of sine of x to the 4. And as you see, we have three functions sitting inside one another. So derivative rule says always take the derivative of the outer function first, but leave the inner function same. That's the chain rule. In here, 5 is not a constant, it's a coefficient. So when we have a coefficient, we leave it alone. We bring our 5 down because it's a coefficient. And what's the derivative cosine? Negative sign. So let me put the negative in the front and sign here. But we must keep the inside same. And then we multiply. And then we change, this time, the second function. So a second function, let me change the color, is sine. So we're going to take the derivative of sine this time. But we have to keep our x to the 4 alone. So derivative of sine. What is the derivative of sine? Cosine without any negative sign. But since we have to leave the inside same, so it's x to the 4. So we took the derivative of the first function, then derivative of the second function, and now we still have one more function left. That's x to the 4. So we are going to multiply by the derivative of x to the 4. What's the derivative of x to the 4? 4x cubed. And now we have the derivative of this weird composite function. Now all you have to do is simplify. So if you observe, we have negative 5, and then we have 4x cubed. Put them together, so you get negative 20x cubed. So multiplying this and this term to make it look nicer, we get 20x cubed, and then the hard stuff. Sine of x to the 4 times cosine of x to the 4. This is the derivative. It cannot simplify any further. And they want us to evaluate the derivative at the x value. So derivative, our x value is 0, is negative 20, 0 cubed. Since it's 0 cubed, we don't even have to bother about writing out the whole thing, because what 0 times anything is 0. So derivative will turn into 0 anyway. So this thing is 0. So equation of the tangent line is y equals 0 times x minus 0 plus 5. This whole thing is 0 because 0 times anything is 0. So at the end, we get the simple equation y equals 5. It's a horizontal line. And we have a horizontal line. That's because exactly at 0, we have a bump in the function. Question? Any question? Any comments? Nothing? Can I flip my page? Are you guys done with the left page? Okay, the next one. It says we have a displacement function. A particle moves along the x-axis so that at any time t, its coordinate, x coordinate, is given by this function. So in other words, this function is the displacement function. Displacement function. Means from one place to another place, how it's moving. In A, they ask me for the velocity after 1 second. What is velocity? Derivative of the function. So basically, you're looking for the first derivative. So let's say x prime. Actually, I shouldn't write x prime. So here, what I'm going to write is this. We know our x is this. The whole equation. 4t³ plus 5t plus 9. Now, x is a function of t, right? So our independent variable is t, and our output or dependent variable is x, right? Now, we are finding derivative of this x, and on the denominator, we indicate what is our independent variable. So what is our independent variable here? T. So I should write dx over dt. It means we are finding the derivative of the x function where our independent variable is t. Or we are finding the derivative of the x function with respect to the variable t, where t represents time. Okay, so this is another notation of derivative, which we are going to learn more in details in explicit or implicit, I forgot which one, implicit differentiation section, which comes after your exam. Okay? So right now, just remember, f prime, it means derivative of f respect to x. Instead of writing whole df over dx, we simply put f prime, and everybody understand, well, it's derivative of f, and anytime we find the function, usually our independent variable is x. So df over dx is same as f prime. Or y prime is same as dy over dx. It means our function is y, but it's respect to x. So we already know every function has y equals some type of x. So we don't write dy dx all the time. We simply write y prime or f prime. Now, if you write x prime, it's unusual, right? Not every function a name is x, right? But every function has name y mostly, or every function has name f of x. So these are general normal term, and when you bump into some abnormal thing, unusual thing, you have to write it down, everything in details. This is the variable we are taking the derivative of, and in this function, our independent variable is whatever is in the bottom. Clear? Any question? But you're going to do the exact same thing. You're going to take the derivative anyway. This is just notation. So what is the derivative of 4t³? Sorry. What's the derivative of 4t³? 12t². Derivative of 5t, 5. And this time 9 is a constant, not coefficient. So what's the derivative of any constant? 0. In other words, our first derivative is simply 12t² plus 5. So this is the velocity. Now they're saying, well, this time t is 1. So when t is 1, our dx dt becomes 12 times 1² plus 5, which is how much is 12 times 1² plus 5? 17. So after 1 second, we're going to have velocity 17 meter per second. It's meter per second. How do I know? Because they're telling us a displacement in terms of meter, and we took the derivative with respect to time, and time is in second, 1 second. So velocity has unit something over something. Now, second, they want us to find the acceleration. What is acceleration? second derivative. So that way we indicate that is this. So first derivative is only dx dt, and it's 12t squared plus 5. The second derivative we write as this, dx dt. But this time, in order to tell others that this is a second derivative, we actually put a 2. So d squared and then on the denominator, the power goes on the variable, not on d. So d to the power your function divided by d and then independent variable square. That's how we represent second derivative. So let me write it down in case if you forget later. This is second derivative. So what is the derivative of 12t squared? 24t. And what is derivative of 5? 0. So when our t is 1, d squared x over dt squared becomes 24 times 1 plus 0. Wait, this is 0, not 5. And I don't have to write 0 here, which is 24. Can you guess the unit? Meter per second squared. The t squared means you times square. So it's meter, you are still going that much distance in second square, because this is your second derivative. Any question? No? Do I explain things so well that you guys have no question at all? Or you guys didn't understand? And too shy to ask me question. Which one? The second one? Too shy to ask question? Just ask it anyway. Ignore everyone else, okay? Think you're the only one in the classroom and you didn't understand something. So ask me, which part you did not understand? Where did I get time? Because they are telling us in the equation, our x is in meter, and they're telling us what's the velocity after 1 second. So second is our time. So the first derivative has meter per second, because look at the numerator. This is the meter, and this is the second. So meter per second. And the second derivative, we still have meter per second square. It's not meter square, right? Because still have same distance. So it's meter per second square.
What's the variable of the X1 and the variable match the X1?
Whatever derivative you're taking, that goes to the power on the denominator, on the variable. And d, with whatever derivative you're taking, it always goes to the d, not on the dependent variable. Probably that's why dependent variable doesn't have any power here. So dependent variable is meter, but independent is second. So meter is still meter because we don't have the square on x. We have square on d. Any other question? No? So this time, our function is sin x. It's a cool, nice function. And we are going to find 8 derivative, up to 8 derivative, and see what can we observe there. So start with the first derivative. What's the derivative of sine? Cosine. And second derivative means take the derivative of cosine. What's the derivative of cosine? Negative sine x. third derivative means take the derivative of the negative sign. So what's the derivative of the negative sign? Negative cosine. And now fourth derivative says take the derivative of the negative cosine. So it's sine because negative sine. Derivative of cosine is negative sine, but you already have a negative in the front, so it turns into positive sine. See, after 1, 2, 3 cycle, the sine function becomes sine function again. Now let's see if it's true for other derivative also. Now fifth derivative. So fourth derivative is sine. Now fifth derivative is cosine. Then sixth derivative is negative sine. Seventh derivative is negative cosine. And lastly, what's the eighth derivative? Sine function again. So it is true. After every 3 iteration, the sine function becomes sine function again. And what do you observe about the power, the derivative? Which derivative gives us the same derivative back, same function back? The fourth derivative, the eighth derivative. Can you guess the next derivative? 12. So it's like a multiples of 4. Every multiples of 4 will give you the same sine function back. Only sine. Cosine has its own iteration. So for sine, it has multiples of 4. Every multiples of 4 gives us the same sine function back. Now, based on this observation, we have to find out what's the 99th derivative of the sine function. You already know this, Ellen. You told me the answer last time. Let others think. How do you think you can apply that knowledge to figure out the 99th derivative? So 99 mod 4. It means when you divide 99 by 4, how much is the remainder? Okay, let me write this down. 99 divided by 4 is how much? I mean, the remainder is how much? I should write. Remain. I don't have space. 99 divided by 4 gives what remainder? This is what modulo means. 99 modulo 4 means divide 99 by 4 and tell me what is your remainder. So 4, if you divide 99 by 4, how much leftover we have? 1, 2, 3, which one? 3. That means we have a sine function and you're looking for the third iteration of the sine function. 1, 2, 3, negative cosine. Cosine, sine. Sine, so you go 1 unit back. It's much easier. So, yeah, let me show you both. So if you do this, our remainder is 3. That means you're looking for the third derivative, basically. So first derivative, second derivative, third derivative. This is your answer, the third derivative. And we already know our third derivative is negative cosine. So our answer is negative cosine x. Correct, Ellen? Okay. Now, second method, we know 100 goes to 4, 4 goes to 100 evenly. So D100 D100 of the x100 of the sine x is same sine x. Anytime you can divide your power by 4, that means you have sine. Okay, this is what it means. So you have 100 derivative is sine, and 99 is only 1 unit back. So when you go 1 unit back, it gives you negative cosine. So that's how that tells us that you don't have to find modulo if you don't understand it, just go forward. So either you can go forward and then take a step back, or you can stop before you go to your destination and then count how many places you need to go to your destination from a multiples of 4. 2 ways you can do it, okay? Or maybe you can do even more ways. Any question? Yeah. Okay, then I have a bunch of example, and also you have d to the 86th power. It means what is the 86th derivative of the sine? Figure that out, and you have a bunch of others. Try them, and it's a prayer time where you pray, and then you'll do them together. Okay? Do you mind if I pray here? I am not going to distract you, right? Thank you. So don't mind me, okay? I'm just praying. You don't have to do them alone. You can talk to your neighbors and do them. Or you can do them alone and then check with your neighbors, whatever you prefer. So how far did you guys go? Which question? Ellen, have you done it everything? Number 9? Okay. How about other people? Are you guys done with 1? All of you? Question 1? Question 2? Not yet. How about question 3? Kimberly? Carrie? Judith? Mac? Ziad? Where? What happened to your homework? The lemon homework. What happened? I noticed it last night. I was like, seriously? Make sure you do all of them. Chi? Jocelyn? Lucas? Hoy? Logan? And Ellen here. Musfika? Nick? Sanzim? Shian? Shian? Online. You're supposed to be here in person, Shian, not online. Raka? Ella? Apollo? Andy? Is there anybody whose name I did not call? So everybody's here? Cool. So what do you want to do? Go over one by one, or you want to complete them by yourself first? Complete them together or alone? Alone and together? Okay, then I'm going to give you 10 more minutes. Complete whatever you can finish in 10 more minutes. That's just and what's that response? Right? It's negative. The next one is why the next oh get the ATP. So that's the root of x squared, which is and then you choose to the negative one. So y becomes 3. No, it's where you have this x to the negative 1 part. And the negative 1 part comes down. And the negative 1 this doesn't come. And then negative 1 part minus great. And in the next one, you can make even negative y. So all those x to the power come down to the and we have 2 in the function on the denominator. denominator. 3 is already on the denominator, right? And so here, 3 is already on the denominator. So the negative power comes down next to the denominator. Why is it 4 times the power? So currently you have 1 part, right? And then this whole thing comes down. Oh, it's great. No problem. No worries. Um, Plus or times. Oh, then you must put the parentheses. Um, think they are asking for just the derivative economics, yeah, but mostly they're asking for Tenderman. Tenderman is used to top, so it was just used that is something like something. So now it says x cubed plus 9x. Oh, think to the power. Times extra plus 5. And this whole thing to the power. Okay. Yeah. So you have to take the derivative one at a time. Yeah. You like it, let's say. Yeah. How are you? Good? Right, we will look different. So, what happened to the power? What happened to the power? Oh. So power comes down, or minus 1. That goes to the top. And fortunately, attendance. The attendance is very poor. So, oh, you didn't get the email from me and from Arjun? I saw it after. I was here. Send me an email from the email you have in your phone. Send it right now. I'll tell you. So I'm gonna send an email. Actually, do all of you guys check your answer email all the time, every day now? Then all of you send me an email right now with your, from your phone. Send the email here. Jannah Jannah dot Shahera at gmail.com. Okay. Whatever phone you have in your phone, whatever you always check, from that phone, send me an email right now in this email. So I'm going to make a group with all of you. Anytime I need to tell you anything, I'll just send it from my Gmail. And then you'll have no excuse that you didn't receive it. I didn't see it. Ella, I should do it right now with your phone. Oh. Jannah dot Shahera HERA@gmail. How are you doing? Tired? Me too. So how was you go? Why is not take the pattern para with the pattern or down in a square. The denominator is square. Outside, keep the inside. And multiply with the second function. You can do it, but keep the inside for the second function. And you keep doing it until you run out of every function. So this one. For this one, so I'll just not. The sign becomes cosine is a negative cosine is negative signs, and the sign is negative, so you cannot change any function. Oh, I can't change. Like that. You can change only one function. Okay. So if this time you're changing cosine, that means you cannot change any function. Oh, so first I'm sine x, and then like so. That's x. If cosine, they just cosine is negative sign, but you see that you use it alone. Square has one. Yes. And when I have to find it. Now multiply by, so you took the cosine, so you took the sine with the cosine, and now part function will be so multiply by that function. I want to put it to these two x outside. So it's x2. So it's always look at the original one. Give the sign, cosine, with the multiply by the cosine, and then with the mean side. And then multiply by the last function, and then square parameters like that. What kind of cosine? It's so it's the whole thing has its root. Its root means which power? One power. So this whole thing to the one power divides. And now it's like a power. Power comes down, power minus one. This is the power rule for the chain rule. So we have two functions, one is the power and one is the power. So you already doing the power rule. The power says power comes down, power minus one. That's the power. So when you change the power, you cannot change the inside. So you're leaving inside function same, and your final power. And then you multiply by the return inside. Keep the inside function first. Write the same thing. Put parentheses, And then when the power comes down, and what is power is what plastic is what that trace the power. You're done with the power. And now multiply by the weight of this, and we put it inside the by this. The different days you're done, but the thing is, you cannot really make it up. In the next line, which is the fraction, you have one on the top, you have two of them invisible, and you have this on the top, right? So put that on the top. And then we add the bottom, and when we organize the whole thing comes down, we write all together, right? What is the whole? And we just two close to the factors. But that two there's no point in which is quotient. Anytime your fraction is quotient. What's the quotient here? We divide the original meaning smaller. Here. Time to 11 function. You will find the quotient root. We just stated the quotient roots. Times it's not. No. Why do you know the denominator? Oh my God! See, what are you doing? What are you doing? No, minus. So yeah. Together since we don't have much time. We have 1 hour. How much time in here? These are challenging, right? Hard. You'll see them in the homework. Most of them I took out from the homework actually. So if you do them here, I'm helping with your homework. Let's do this question first. Where we are finding tangent line, one more tangent line question at x equals 0. And then we are going to do the rest one by one. So we have f of x is 2 cosine x plus 3x. Actually, you should do it. This is much easier than what we did previously. Find the equation of the tangent line by yourself. And remember, equation of the tangent line is whatever I gave you before. Either this, or you find your slope fast, your y-intercept, and then put them together as y equals mx plus b. It's up to you. You can find m, you can find b, and then write as a slope-intercept form, or you can just write point slope format by finding this is your m, and then this is your y value for your x value 0. So this will be a good practice for the exam question. You'll see one of these in the exam. Find the equation of the tangent line. No, this x is not 0. This x is in the equation. So anytime you have the equation, you have your x and your y. So x and y, this x and y, you're not going to do anything with them. These are really fixed. Okay, that's minus 0. How many take? How many 1 0? So that's I'm going to use what is the 0? So this is 2, and then 1 you have 0 here, some 0 0, 0, 3 0. So square is 3, x minus 0, your y value is 2. So y value of 0 is 2, right? So it's of 0. It is a of 2, but okay. So say 2. Not 2, 0. It actually 0. So what is f? No, with f of 0, not found. Because we only have to find here. So f of 0 times x minus 0 plus f of 0. F of 0 is 2. How come we have y equals 2 now? So this is derivative at 0. So, and your y value is 2. And your v is 2. Oh. Okay, so your equation is y equals mx plus b. X and y, they are fixed. So m is the derivative. What's the derivative? So your m derivative and zero. Right? So what do you have? How much is it? So y equals 3x. Now plus 3. How much is it? Zero. Equal to, perfect, equal to, right? And, okay. Derivative running to find how much is the derivative? So if you want to you derivative slope, just have to be slope to one while you it's going to say what is it again? How is it? Exactly. You're evaluating at a equals x equals 0, right? X 0 is a. So this form is just a form, but see this looks weird x minus 0. For example, if it was a different number, maybe it was acceptable, but x minus 0 is not acceptable. The number is minus 0. Many people have no idea. Great. Okay. So first we find the y value. So our x is 0. We need f of 0. So 2 times cosine 0 plus 3 times 0. This is automatically 0. Cosine 0 is 1. So we get 2 times 1. That means 2. Then we find derivative. Derivative of x. So derivative of 2, it's a coefficient. We'll leave it alone. Derivative of cosine is negative. So let me put the negative in the front. Sine x. And derivative of 3x is 3. So derivative is a function. We don't want a function. We want a number to plug in into our equation. So that's why we need to substitute all the x with 0. And we get negative 2 times sine of 0 plus 3. Now what is sine of 0? 0. So what do you get here? 3. Now the equation of the tangent line is y equals derivative at a, x minus a plus the y value at a. All of these a are 0 because our a is 0, they give us. So when you substitute, we get derivative at 0 is 3. X minus 0 is simply x. So we don't even need the parentheses. The y value at 0, we found 2. So we put plus 2, and this is our equation. Okay? Any question? Okay, then let's do this one by one and enjoy. Anytime you take the derivative, first step always should be rewrite your radical using exponent. So it will be easier for you to apply the power rule. So y equals x squared and 1 over cubic root of x. It becomes what? As a power, as an exponent. Negative 1 over 3 plus square root of x, x to the 1/2. And now it will be easier to take the derivative. So what's the derivative of x squared? 2x. And now the power rule. Power comes down, power minus 1. So power comes down, and then power minus 1, x to the what power? Negative 1/3 minus 1. Negative 4/3. Plus, same thing, power rule. Power comes down, power minus 1. So 1/2 comes down, 1/2 minus 1. X to the what power? Negative 1/2. And 2 is a constant. What's the derivative of 2? 0. Now you're happy, you're done with the derivative, but you have to make it cuter, nicer. Okay. So we first go for double negative. What happens to the double negative? Positive. So y prime is 2x plus, and then you see the second term has a negative power. We cannot leave any negative power alone. We have to put it as a fraction. Now the second term already has 3 on the denominator, right? So keep it 3, and this whole expression comes down on the denominator, x to the 4/3, and becomes positive power. What goes on the top? Only 1. We have this one, we have no other number, so we bring it down. Same thing happens to the other one. We already have 2 on the bottom, and we want to bring the negative 1/2. So either you write x to the negative 1/2, or to make it even more nicer, you write square root of x. And again, we have no other number besides 1, so 1 goes on the top. So this is the derivative. And now I'd like to do one more thing. Let's say I'm telling you your x is 1. Then what would be the derivative when x is 1? The first one is easy, right? 2 times 1, 2. And when x is 1 in the second term, the whole expression becomes what? What is 1 to the 4/3? 1. 1 is a very generous number. It doesn't matter what power it has, it always gives us 1 back. So this is 1, so we have 1/3 times 1, which is simply 1/3. Same thing on the third expression. What is square root of 1? 1. And 2 times 1? And 1/2 is 1/2. So we have 2 plus 1/3 plus 1/2. How much is the total? By the way, you are allowed to use calculator. Scientific calculator, not graphing one. Let me guess. It will be 5, 6 plus 2, 12 plus 5, 17, 6. Is it correct? Is it? 17/6? Cool. See, I did it mentally. Wonderful. Do you want to know what I did? The LCD between them is 6, right? So you multiply 2 times 1 gives us 2. 3 times 1 gives us 3. So 2 plus 3 gives us 5. So we have 5, 6 here. So 2 plus 5, 6. 6 on the bottom, we multiply 6 and 2. We get 12. And we add the top plus 5. 12 plus 5 is 17. And we have the denominator 6. That's why I did it mentally. Any question on this one? No? The next one. Many of you may think, oh, all I have to do is take the derivative of each one and multiply, right? But guess what? It's not, right? What rule is supposed to use here? Which derivative rule? Product rule. So let's say this function is f, this function is g, this function is h. We have 3 functions. The product rule says, take the derivative of the first one, but leave the other 2 functions alone. multiply it with the derivative. And then you always add, never subtracting the product rule. You take the derivative of the next function, which is g prime, but leave the other two functions alone. So other two function is f and h. We have to leave them alone. Plus, and now we changed f, we changed g. Now it's time for h to be changed. So we take the derivative of h, but we have to leave the other two function alone next to that. So it's fg. So this should be the outline of our result of the product rule. Now all you have to do is find the derivative for each one of them. So our f function, now let me change color. Our f function is x squared. Actually, let me do this. F function is x squared. Then what is f prime? 2x. Our g function is cosine x. Then what is g prime? Negative sine x. So this is the second function. Now our last function, h, is cotangent x. Oh, I don't even know what's the derivative of cotangent x. Ellen, what's the derivative of cotangent x? Negative cosecant square? Okay. Negative cosecant square. He's correct, right? I trust him. Okay, so we have all the derivatives. Now all you have to do is put them together into the equation. So our f prime of x, f prime is 2x. So we write 2x, but we have to leave the g function and h function unchanged. So cosine x, cotangent x. That's the first part. Then we add the second function. So second, we are multiplying by negative sine of x. Because of that, this sign will become negative sine of x, but we're going to keep the x squared and the cotangent. So x squared and cotangent x. But it does look weird, right? Two trig function on two sides and x in the middle. So let's rewrite so that it looks nicer. X squared first, sine in the middle, and then cotangent x. In multiplication, you can move around your function whatever way you want. It doesn't matter. And then lastly, we multiply by the derivative of cotangent. So we have another negative sign. Negative cosecant squared x. And we have to leave the x squared and cosine. So x squared and cosine of x. And now you're done. This is the derivative of this function. And I color coded for you so that you can easily understand what I did. Question? So what do you think about the derivative? Are you guys ready for the exam? Some of you are, some of you are not. I'll try to give easy ones and harder ones. So if you're okay with easy ones, you can do all the easy ones. And if you like challenge like Ellen, you can do the harder ones. Extra credit, I can try putting extra credit, but then you cannot have anything more than 100. So with all the extra credits and everything, the maximum we can get is 100. It's okay, right? You can have up to 100. Okay. So I'll give easy question, harder question, so that all of you can pass. Fair, right? I'll be nice to you guys. Okay, the next one. Which rule? chain rule. But like I said, we don't do anything until we rewrite any type of radical into exponents. So fifth root becomes what power? Huh? 1/5. So f prime of x. The chain rule says, first work with your power, apply the power rule. When you apply the power rule, don't change the inside. So leave your inside same, just work with your power. Work with the power means bring the power down and then power -1. What is 1/5 minus 1? -4/5. So you're done with, what is this, 1/5? So you're done with one portion of the function. And remember, derivatives says always can change one portion at a time. So we changed the outer portion, we left the inner portion same, and now it's time to change the inner portion and multiply by that. So what's the derivative of the inner portion, the inner function? 3x squared minus 2. So you're done with the derivative. But are we done completing the question? No, right? Anytime you have negative power, don't leave it alone. So what goes on the bottom? We already have what on the bottom? 5. And now next to the 5, what is coming down? X cubed minus 2x. And its power become positive 4/5. Any negative power always have to be on the denominator. Now what goes on the top? 1 and then 3x squared minus 2. But this 1 is 1. So we actually don't write 1, it's 1. If it wasn't 1 but something else, you must have to write this number down. For 1, ignore. For every other number, you cannot ignore. And that's how we have this on the top and denominator on the denominator. Any question? No? Next one, a fun one. Secant squared square root of x. What do you think? Apollo. So it will be easier for you to see what's going on if you rewrite this way. If you rewrite this way, then you can see we have to use chain rule. Anytime any trig function has a power, we can actually move this power outside of the whole thing. But we cannot move anything that is inside your secant function. Like square root of x, we cannot write 1/2 on the outside. However, we can write this. Okay, we can write this, but we cannot put 1/2 outside. We can only put a 2 outside because secant has 2 power. Okay, go ahead, Apollo. 2 secant square root of x times. So 2 comes down, 2 minus 1. So secant root x doesn't have any power. And then you multiply by the secant. What is the derivative of secant? Derivative of secant is -10. Only 10, right? Only tangent square. Secant and 10. Secant and 10. But what goes inside? Square root of x. So we change power, we change secant, and now our last thing you have to change is this. What's the derivative of the inside? Square root of x. 1/2 over square root of x. So we have three things. One is the power on the secant. Power comes down, power minus 1. That's how we have the second term unchanged. This is our second term. We did not change it because this is same as this inside. We wanted the power, we left the second part alone. And then we went and changed the secant. Derivative of secant is secant. This should be C. Derivative of secant is secant and tangent. But when you change the secant, we have to leave the x square root of x alone. So we changed secant, but we left the square root of x alone. And lastly, we went and do square root of x, which is this. So 3 portion of the function gives us 3 parts in the derivative. And then we simplify. So we have 2. How many secant x we have? 2 of them. So secant square x, tangent x, x means root x, and on the bottom we have 2 square root of x. What do you observe? We can cancel the 2's. So we have secant square root x, tangent root x over square root of x. You should. At least simplify to something that is simplificable easily. Like this one. I didn't do anything hard. I just combined the like terms. So we have 2 secants, that gives us secant square power, and you have 2 on the top, 2 on the bottom, cancel that. Any question? No? Now, did you figure out what is the 86th derivative of sin x? 4 goes to 86 how many times? Or how many remainder we have? 2 remainder, right? We left 2 remainder. That means we are taking what? The second derivative of sine. So first derivative of sine is cosine, and second derivative, what is the derivative of cosine? Negative sine. So what is our answer? Negative sine of x. Ellen, do you have negative sine of x for 5? You do? Okay. Any question? And since you're allowed to use calculator, you can actually find the remainder using calculator. The next one is very easy, right? Do you want me to go over or I can skip it? Skip it, right? This is also easy. Simple product rule. Let's do one quotient rule to refresh your memory. Do you remember what is a quotient rule? So I'm going to give you one of them, okay? Power rule, product rule, quotient rule, chain rule. All 4 rules you'll see. At least one question from all 4 you must do. So what's the quotient rule? Is switch in position. You always have to take the derivative of the top first. Always. Low D high. Derivative of high is always first. So low D high minus high D low over low square. So this is high, this is low Our high is tangent x. Our low is 2x cubed plus 5. Then what's the derivative of high? What's the derivative of tangent? Secant square. And what is the derivative of the denominator? 2x cubed. What's the derivative of 2x cubed? 6x squared. And derivative of 5 is 0. So now all we have to do is the derivative of y is y prime or dy dx, whatever you prefer. And then we take tangent, derivative of tangent is secant squared x. We multiply by our denominator 2x cubed plus 5. And I don't have space, so let me do minus here. Our denominator is 6x squared. And we multiply by tangent x. Whole thing divided by denominator square. 2x cubed plus 5 square. You can leave this alone if it's just telling you to find the derivative. Then you can leave it alone. However, if they're asking what's the horizontal tangent line for this function, then you have to simplify the top. Okay? So for this exam, I'm not going to ask you. I already see many confused face. So I'm going to keep my exam simpler for your sake. But still it will be hard, okay? Because you have so many materials to cover. All those limit rules, all those derivative rules, one-sided limit, exact limit from the graph, okay? Let's see which one looks more interesting next. Oh, let's do these. So the rest are similar things. Quotient rule, chain rule, blah, blah, blah. Let's do 11. It's fun. We have three functions that we say to take the derivative 3 times. First function. When you take the derivative of one function, remember, you have to keep your right side same. So what's the derivative of sine? Cosine. But you have to keep the entire right side same. So what goes inside cosine? Cosine of x squared plus 1. And then you multiply, change your next function after cosine. So your next function is this. So what's the derivative of cosine? Negative sine. But you have to leave your right side same. So what goes inside sine? Negative sine? X squared plus 1. And then you go to your last function, which is x squared plus 1. So what's the derivative of x squared plus 1? 2x. That's how we do chain rule. Change one function on the left, keep everything else same on the right. Then go to the next function, change it, but keep everything on the right side same. So we're done with the derivative, but it looks ugly. So let's clean it up. How can you make it a little bit cuter? What goes in the front? 2x. How about the sign? What's the sign of the entire thing? Negative. And then we have a simpler sine function. Let's put it first because it's simpler. And then we have complicated cosine. So we get cosine of x squared plus 1. We just rewrote. We didn't do anything different. We rewrote, but now it looks a little bit cleaner. Question. What do you think? So which one is easier? Power rule, product rule, quotient rule, or chain rule? What do you think? What do you prefer? Product? That is true. Product rule is the easiest one. And then quotient or chain? Which one? Chain? Chain rule is fun if you have this type of chain rule. And if you have a power, are you comfortable with the power rule? Like the one we did here? On the left page. What do you think about the power rule for the chain rule? You guys are okay? Power rule and chain rule? Okay, so we did so many derivative questions, and now let's do something unusual with the derivative, but something much cooler. Okay. It says, suppose g of x is a function where g of 1 is 4 and derivative of the g at 1 is 2. Now they're giving you a function. F of x is x cubed times g of x. So f of x is x cubed times the g function. They want you to find derivative of f at 1. That means first you have to find what's the derivative of f for any x. What do you think? Anyone else beside Ellen? Any idea?
Is product rule.
Product rule. So what's the product rule? 3x squared times g of x Great. Ellen, is this what you have? Same thing? Even though they did not tell us what is g function, but since we are so smart, we know derivative of g of x is simply g prime of x. It could be any function. We don't care. The main idea is derivative of g is g prime. And now they want us to substitute all those x with 1 and see what happens. So we have 3 times 1 squared g of 1 plus 1 cube g prime of 1. So all those x turn into 1. X is 1. X is 1. This x is 1. This x is 1. All those x's turn into 1. And now, what is 3 times 1 squared? 3. Do we know what is g of 1? Did they tell us what is g of 1? How much is it? 4 plus, what is 1 cube? 1. And do we know what is g prime of 1? 2. So in other words, we have 3 times 4 plus 1 times 2. How much is the total? 14. That's all. They didn't give us the function. We don't care. The smart thing is here that anytime any function, its derivative is the same thing with the prime on the top. That's it. Any question? Any comments? Nothing? Then try this one. Two of them. Basically, they are telling in the first function that what is the derivative of f times g. And on the second one, they're saying what's the derivative of f divided by g. So this is product of f and g. Product of f and g. This one is f over g quotient. If it looks confusing, we can rewrite this as, let's say h of x is f of x times g of x. This is what it means in the first one. And second one, they're saying h of x is f of x over g of x. And they want it to find h prime of 5 in both cases. No, 7:20. Very early. Yeah, I had 10 more minutes. Do I have more? Two more. Well, you wanted this next song. Because they're fun. Oh. One, two, three, and so F five, F5, five, two, into F of 5, 1, D to G, is that 4 or 7? Right? Let's start that. The next one, this is the next one. The new one. The rest is the new one. Yeah. Two companies multiply together, put A to B. The product of Now they want to do it with everything at 5. So all the contacts kind of 5. Okay, and second, right under the previous one. Pretty section. So try the next one, right? Number 2. Your properties. 764. 3.86. That's it. It is powerful. I need to use it to take the money. And really feel the position for me is one way to go. So, why are these okay with the product maintenance? There are 2 parts. I need to combine them, right? You combine them together. Alright. This is what you know. Here you have 2 functions together. F(x) and g(x). What's the derivative of f(x) and g(x)? Which derivative do we have to use? When we have product of functions. Product. What is the product? Derivative of the first function, type the second function. Plus derivative of the second function, type the third function. Why don't you find? How do you think? Why do you want to it's only 15? Second one is 75. Ellen, what's the answer for the second one? 70? Nine. So what is the difference? Into F. You're finding derivative at 4. So F prime. Actually, write this out first. Because what you do is first find your derivative here. Because when you write the derivative, you will see that. And then. We change the F, and now you can change the final X. The final X. And now all the X becomes 5. So similar to that. Or they give us more information than what we need. Okay, so let's do them together real quick. h prime of x, it means you're using the product rule. Derivative of the first function, leave the second function alone, plus derivative of the second function, leave the first function alone. And they want us to evaluate that at x equals 5. So h prime of 5 is derivative of f at 5 times g of 5, derivative of g at 5 times f of 5. So f prime of 5 is 7. G of 5, oh, sorry, my bad. F prime is on the top, not on the bottom. F prime is 5. Our G is -8. Then G prime is 7. And our F is 1. So -40 plus 7, that gives us -33. The first one. For quotient, we have h of x as f of x over g of x. So all you have to do is take the derivative rule for the quotient. F prime of x times g of x minus g prime of x times f of x, whole thing divided by g of x square. And then you substitute everything. Then so it will be -47 over what? Huh? 64. The last one is chain rule, because we have two functions sitting inside one another. F of g of x. So to find f prime, first we change the outer function f, but we have to keep our g of x same. So first one is done, then we go to the next one, g prime x. So we are evaluating everything at 4. So f prime of g of 4 times g prime of 4. Oh, that's why they gave us more information. So we find g of 4. What is g of 4? 5. So for the first one, it's f prime of 5 and g prime of 4 is 3. So you go to f prime of 3. Sorry, f prime of 5. That gives us 3. And we still have our 3. That's how we have 9. Let's do the last one real quick. Sounds fun. Looks fun. So we have h prime. So it's 7 plus 6 f of x with the power 1/2. So 1/2 comes down, 1/2 minus 1. That's the outer function we are changing. That means you have to leave the inner function same. So 7 plus 6 f of x. And then we multiply by the inner function. What's the derivative of 7? 0. And 6 f of x. 6 f prime of x. And they want to substitute x with 1 here. So let's rewrite nicely. 2 is on the bottom, and then square root of 7 plus 6 f of x goes on the bottom. 0 plus, so 0 cancel out. We have only 0 get rid of, so you get f prime of x. But then every x turn into 1. And now we have nothing to do because we have everything. We can cancel 6 and 2, we get 3. Because they are multiplying both on the top and on the bottom. F prime of 1, 4. And then f of 1, 7. So 12 over, how much? 49. So 12 over 7. So this type of math are like logic. They're using how much you understood about the rules. If you don't see a specific function given to you, just in general idea, how can you work with the general idea of the derivative? So let me tell you real quick what will be in the exam again. And if you already forgot anything, go back, watch the recording, and then you'll feel comfortable. So identify left and right-sided limit from a graph. For example, you have a graph, something like this. You identify what's the derivative when it comes from the left side, what's the derivative when it comes from the right side, and what's the derivative exactly at that point. It is from graph. We did it at the beginning. Go ahead and check. The next one, sketch a graph with this type of information. For example, renewable discontinuity at 1. Renewable discontinuity gives us what? A jump, a hole, a vertical asymptote. Which one? A hole. So you're going to draw a function where when x is 1, you have a hole, and then jump discontinuity at 6. So for example, maybe this is 1, so you have a hole there, and let's say this is 6, so something like this. At 6, you have a jump discontinuity. At 1, you have a hole in the graph. Your function could be anything. Ignore that because I didn't tell you this. Find domain, renewable discontinuity, horizontal, vertical asymptote. One question with 4 parts. And then we have different types of limit. Anytime you're finding the limit, what is your first step? Always substitute. So when you substitute, you get a number of a number, you are done, you stop. This is the easiest one. The next one, when you substitute and you get a number on the top, but 0 on the bottom, that means you're working with vertical asymptote. And for vertical asymptote, you have only 3 choices for the limit. What are the 3 choices? The answer will be what? Either infinity or negative infinity or dne. So you're not going to get a number, okay? You have 3 choices only here. How can you do that? You take a number that is very close to your limiting value, substitute from the left, substitute from the right. So here it's -1. So pick something from the left of -1. Let's say -1.1. It's on the left. Sorry, -1.1 is on the left. So this is the left limit. And then you pick something from the right. Let's say -0.9. It's on the right side, right? So this is the right limit. And you observe the sign. 0 over 0. You can never get 0 because you're working with rational. So you have answer on the top and answer on the bottom. All of these are rationals, okay? For polynomial, you can get a 0, it's fine. But for rational, you have to have 1 answer on the top, one answer on the bottom. Asymptote? Okay, I'll do that. But let me tell you what will be in the exam. So left side limit, take 1 point, right side limit, take 1 point, and observe their sign. Not the number, you don't have to worry about the number, sign. If the sign is same sign for both, your answer is positive infinity. If you have the same sign for both, your answer is negative infinity. But if one is positive, one is negative, the answer doesn't exist. Then the third one is the most important one, 0 over 0. 0 over 0 means something is wrong with the function, so modify your function based on what type of function you have. For example, here, you're going to do factor and cancel. But for the first one, what's the step for the first one to modify? Rational is the conjugate. Rationalization. So for now, you have two choices, either rationalize or factor cancellation. And then you resubstitute, and this time you're supposed to get a result. If you still don't, that means the derivative doesn't exist. And this will give you a number, either a number or doesn't exist. Okay, two choices. And then you have piecewise. For piecewise function, you'll get a number, not infinity. So either number or doesn't exist based on what they're asking. So here for the anything not 6, this is your function. Anything equals 6, this is your function. And to see whether the limit exists or not, you have to see whether the both equations give us the same y value. As long as they give the same y value, this function has a limit, and that's the limit you have. If you get two different limits, that means the limit doesn't exist. And here they're asking for C. What makes this function continuous at C? Continuous at x equals 3. So you set two functions equal to one another, solve for C by substituting x with 3. And if you can simplify fast, simplify that. Otherwise, just set both of them equal to one another. So I actually explained everything in details in class lecture, okay? So if you forgot anything, go back. All the recordings are on YouTube. And then we have infinite limit. So for infinite limit, you just need 3 rules. The top power and the bottom power. Top power and the bottom power. If the top, let's say x to the m over x to the n. If m is bigger than n, so a numerator is bigger, you have to substitute the infinity and see what sign you have, positive sign or negative sign. So either you have positive infinity or negative infinity, two choices. And then if your top is smaller, then your limit is always 0, always. And if they both are equal, it doesn't matter whatever function you have, as long as the highest power are equal on both top and bottom, your limit is their coefficient, okay? And this is also the horizontal asymptote rules. If your top is bigger, you don't have any horizontal asymptote. If your bottom is bigger, your horizontal asymptote is always y equals 0. And if you have both top and bottom same power, your horizontal asymptote is y equals their coefficient, a over b. This is a, so let me use this. If you have a over b, then it's the coefficient. Then the trig, for trig, you have to remember the table I gave you, not the tables. There are few identities I gave you, remember? Sin x over x, when x goes to 0, the limit. What's the limit? 1. Same thing, x over sin x, the limit is also 1 when x goes to 0. But cosine is different. Tangent is same as sine. So remember all those rules, and then you can do this type of limit. Only sine, cosine, tangent. One question about intermediate value theorem. If you forgot what is that, go back. Ignore this. Ignore this. Ignore this. And then from derivative, one tangent line, find the equation of the tangent line, one, where the tangent line has horizontal, where the tangent line is horizontal, one question, and then five questions from five different types of derivative. Chain rule itself has two, okay? One is function inside function, and one is the power. So chain rule has two, and then the other three, whatever. So this is the outline of your exam. And now if you forgot the vertical asymptote, to find the vertical asymptote, so let's start with the domain. Domain is always the original denominator not equal 0. So original denominator, okay? Original denominator not equal 0, and then you solve for x from there. And then you simplify, then you factor, you cancel. Now, if you can cancel something, that cancel going to give you removable discontinuity. You set the cancel term equals 0, and you get x equals some number. Now, removable discontinuity is a whole, right? Whole means it's a point, still a point. So you need the y value also. So to get the y value for the whole that gives us the x value, the x value that gives us the whole is substitute into the simplified version. Substitute x in the new function after you cancel everything. Then vertical asymptote is the new function, okay? Everything else is the new function except the domain. For everything else, just go to the new function. New function means the modified function. After the cancellation or after rationalizing, whatever you have left, you look at that function only. Now that function set the denominator equals 0 for the new function. And then solve for x. It will give you a break in the graph. And lastly, the horizontal asymptote, you just look at the highest degree on the top, highest degree on the bottom, and you state what information you have. Okay? Any question? So yeah, the exam will be lengthy because we have so much materials to put in the exam. So don't be late. Good luck. And if you have any question, email me in the Gmail. And did all of you send me an email in my Gmail? If you haven't, make sure you do it tonight, okay? So good luck, everyone. And Xian, you also good luck with you. Could you scroll down so I can see which ones is on the Scroll down. So question 3. And then after intermediate Euler theorem, there are 3 parts. Continuity and continuity and differentiability, ignore the whole thing. That's it.